In 1994, this was open water. No land, no bedrock, no foundation. Just the Arabian Sea doing what it had done for thousands of years before any human being had the idea to stop it. What you are about to hear is the story of how a single architect's sketch on a piece of paper in 1993 became the most photographed hotel on Earth. Not because of what was built on top, but because of what had to be created underneath it first. 3 years of work in open sea before a single beam of the building went up. 2,000 workers building ground that did not exist. 230 concrete piles driven 40 meters into sand that had never been asked to hold anything before. This is not a story about luxury. This is a story about what human beings are capable of when someone decides that the impossible is simply an engineering problem that has not been solved yet. And by the time this video is over, you are going to understand something about the Burj Al Arab that the photographs and the price lists and the 7-star marketing have always obscured. The most remarkable thing about this building is not what you can see. It is what you cannot. Stay with me, because by the middle of this video, you are going to hear something about how the ground beneath the Burj Al Arab was built that will completely change the way you look at every piece of land you ever stand on for the rest of your life. Let us get into it. To understand what happened here, you first need to understand the problem. Sheikh Mohammed Al Maktoum wanted one image, one building, something the world would recognize before it knew the name Dubai. In 1993, architect Tom Wright of the firm Atkins drew a concept inspired by the shape of a dhow sail, one of the oldest and most recognizable forms in Arab seafaring history. The brief was simple and completely impossible. Build a hotel that the world would know instantly. Build it on an artificial island 280 meters from the Jumeirah beach, and build it 321 meters tall. The problem was that the site was open water, the Arabian Sea. There was no island. There was no bedrock within any practical reach. The nearest solid rock formation sat more than 180 meters below the seabed, far too deep to anchor anything to. What there was sand, silt. The sea floor of the Arabian Gulf doing nothing in particular, and about to be asked to hold up $1 billion skyscraper for 100 years. The engineers at Murray & Roberts and Al Habtoor Engineering looked at the site, looked at the brief, and made a decision that had never been made in Gulf construction history before. They would not wait for the ground. They would build it. On July 8, 1994, the position was marked with buoys 280 meters from the Jumeirah beach. There was nothing there. Open water in every direction. A pile-driving barge anchored over the marked seabed position, and workers rigged a hydraulic hammer over the first pile. Each pile was 40 meters long and 1.5 meters in diameter. There were 230 of them to drive. The hammer struck. And with each blow, the pile drove deeper through sand, through silt, downward toward a bedrock that would never come. Because there was no bedrock to land on, these were what engineers call friction piles. Piles that grip the sand along their full 40-meter length rather than resting on anything solid beneath them. The load of everything above, the island, the tower, the 70,000 tons of building that would eventually sit on top, would be transferred into the ground through friction alone. Through the resistance of sand against concrete across 230 piles, each gripping 40 meters of seabed. 2 rigs worked simultaneously. The schedule allowed no waiting. Every pile was load tested before anything was placed on top. 1 weak pile in that formation and 70,000 tons shifts. Slowly, over months, a forest of concrete grew from the sea, pile by pile, invisible from the surface. The roots of a building being planted in open water before there was any ground to plant them in. If what you are hearing right now is making you see this building in a way you never have before, hit the like button right now. It tells the algorithm this story deserves to reach more people who have looked at this hotel their entire lives without knowing what is underneath it. Because what comes next is where it gets extraordinary. With the piles in place, the next problem was the island itself. Temporary sheet piles were driven in a ring around the footprint of the future island. They held back the sea while the permanent island was constructed inside that ring. Rock was dropped on both sides of the sheet pile wall. The island edge had to be designed to resist what engineers call a 100-year storm wave. The largest wave statistically likely to hit that location within any 100-year period. For the first time in Gulf construction history, concrete honeycomb armor blocks were placed around the perimeter, specifically designed to allow wave energy to bleed through rather than slam directly into the island structure. Inside the sheet pile ring, hydraulic fill was pumped in. Sand and water sprayed continuously until the sea inside the ring was displaced. Workers measured the fill level every single hour. Too fast, and the sheet piles buckle under the pressure. Too slow, and the schedule collapses. Over weeks, the slurry settled. The water drained. And for the first time, in a place where only sea had existed for thousands of years, land appeared. 3 years of work in open water to produce ground that did not exist. Vibratory compaction probes were driven into the fill to force the loose, saturated sand dense enough to carry a building. Armor rock was laid over the fill's surface. Drainage pipes were buried in the fill to control groundwater movement. The island rose to 7.5 meters above sea level. The seawall was built to the same height. A 100-year storm could not reach the lowest floors sitting behind it. When it was done, workers trimmed every pile head to within 5 millimeters of the exact same level. The raft that would sit on top of those 230 piles had to be perfectly flat. Blinding concrete was poured over the full base. A waterproof membrane was heat welded across the entire surface, because the Arabian Gulf would spend the next 100 years trying to push water up through that island from below. Formwork went up around the perimeter. Rebar went in. Hundreds of workers tying steel across the full footprint of the raft. 70,000 tons of concrete marked out in timber and steel above a seabed that had been completely rearranged by human hands. 3 years to build the island, then less than 3 to build the tower. 2,000 workers, $1 billion. One building that Sheikh Mohammed wanted the world to know before it knew Dubai. The island was dry, it was stable, it was waterproofed, and it was ready. Everything you see in every photograph of the Burj Al Arab, the sail shape, the helipad, the atrium, the suites, all of it sits on top of 3 years of work that most people who have ever looked at this building have never thought about for a single second. The most photographed hotel on Earth was built from the bottom of the sea up, and the sea did not give it up easily. If you made it to the end of this video, you now know something about the Burj Al Arab that most people who have stayed there do not. Subscribe right now, because this channel keeps going deeper into the stories behind the buildings, the cities, and the engineering decisions that shaped the world we live in. Share this video with someone who has seen this hotel 100 times and has no idea what is underneath it. And drop a comment below. Did you know any of this before today? Because the ground beneath the Burj Al Arab did not exist in 1993, and someone decided to build it anyway.